Finally, we'll be talking about this command. I'm not sure if it's supposed to be pronounced SeparateSpecular or SeparateSpecular, but it makes sense in either case and doesn't matter. In this scene, we're going to be using diffuse lighting and specular. Again, all your lighting calculations are added together from the material block, so the diffuse is going to be added to the specular. We're not using emission or ambient right now. So we're going to be using this kind of bright purple value for the specular. And for diffuse, it's going to be a dark grayscale value. You might not always use such a discrepancy in value, but I'm just trying to emphasize what's going on with the SeparateSpecular command. So if you just look at the scene with only looking at the primary, which is the result of the material block in this case, so we have everything the past commented out, that's just looking at primary, and then we go ahead and turn SeparateSpecular on. You can use SeparateSpecular off, but you don't need to because the default is off. So if you ever use this command, then you would put on after it, like this. And then we go back to Unity, then there's no change. If you're just looking at the primary, then you're not going to see any difference. This command is something that changes what happens after the results of the texture combiners is through. So I'm going to turn that off for now, so we can see what it actually does based on not using it first. So we're going to use we'll look at the texture first. That's just this same grayscale, red, green, blue, and white, down to 50%. And we'll multiply that, based on UV coordinates, by the lighting calculation, and then double that result. Doubling is the standard. It allows you to over-brighten the texture to twice what it was to begin with. In this case, because the values are 50% gray, you could use quad, but you'd never be able to get it brighter than twice this anyway. So again, double is the standard. So let's go ahead and actually look at that, uncomment it, and there we go. So we're seeing diffuse lighting multiplied in. That's constant. It does not change with viewing angle. And then we're going to see this purplish, not separated yet, but specular value moving around the spheres. You see it kind of follows how we're looking, and then we see it when we're looking dead on to these planes. So right now, the magenta color, or the purplish color that we're using, which is basically just there's no green in it. It's got some sort of red, some sort of blue component. It's being multiplied in, and this green has no red and no blue, so it's not being affected by that. It doesn't change from any viewing angle. This is only being affected by that grayscale diffuse lighting. And this doesn't have any blue component, the red color, so that only gets brighter when it has some light added to it. And the blue has no red, so it can only get brighter. So the only time we're actually really seeing that purplish color is in this area of gray, which can get brighter and more red and more blue, because it does have a red and a blue component. So over here, where we have it checkered a bit, it's pretty ugly. And on the sphere, as we're looking down from this angle, here's a good example. This is a hard-edged, high-poly sphere again. You can see the color that as we set it in the inspector, and then as we move it around, it's getting multiplied, and that color just isn't coming through the way we wanted it to. Most likely, not the way I guess I intended it to be. So by using this command, SeparateSpecular on, it's going to happen. Again, this change hasn't happened because I'm not back in Unity yet. That'll happen in a moment. What's going to happen is that we have the diffuse lighting and any other type of lighting, emission and ambient, being multiplied in here as defined in this texture stage, but then the specular component gets added in afterwards exactly as you would see it in the primary calculation, like this. It does not, so here we go. We would be looking at blue on the sphere from this angle, but we see purple in the primary, and if we go ahead and actually use the texture stage again, then we'll see the purple again, because it's not being multiplied in, it's being added in after everything else is done. So it actually allows you to get your specular color regardless of what was there to begin with. And for something that's supposed to be mirror-like, it's probably what you want. For diffuse lighting, it might not be, but yeah, for a mirror-like reflection, which is what you're doing with specular, most likely is what is intended. And it looks a lot better, especially on this plane as we move around. It looks like we're actually getting, some sort of reflection of something as opposed to just some weird, ugly effect. So usually when you have a specular shader, as you'll see on the wiki or looking at the built-in shaders, SeparateSpecular is common. It's used more often than not. So why is it not always used? Well, sometimes it might not be the intended effect. Like I said, generally it probably is. But the biggest reason that you won't want to bother with this is that it doesn't work on the iOS devices. It's terrible, but a fact of life. I'm not sure about using OpenGL ES 2.0. I don't know anything about CG or a programmable pipeline yet, so I can't tell you what you would do there, but you wouldn't be using ShaderLab. But when you're using the fixed function pipeline, it won't work for you, unfortunately.